Imagine you walk into a party, a room full of strangers, drinks in hand. And I walk up and make you a bet. I bet you, real money, that two people in this room share the exact same birthday. Same day, same month. A perfect match. You look around. Not a huge crowd. And 365 days in a year. Barely enough people to dent a calendar that big. So you take the bet. Of course you take the bet. It feels like free money. Here's the thing. If we played that bet over and over, I would win more than half the time. More likely than not, in a room this ordinary. That sounds impossible. It even sounds like a lie. By the end of this, you'll see exactly why it's true, and why your gut was fooled so badly it would have cost you the bet. Let's nail down exactly what we're claiming, because the details matter. We're not asking if someone shares your birthday. That's a different, much rarer thing. Forget about yourself for a second. We're asking, among all these people, is there any pair that matches? Any two of them, anywhere in the room. And we'll assume birthdays are spread evenly across the year. No leap day weirdness, no twins, just one random day each out of 365. That's the whole game. Take a room. Hand everyone one day of the year at random. Then ask, did any two people land on the same day? The claim is that even a surprisingly small group usually land a match. Before we do any math, let's get your gut on the record. Here's the question. How many people do you need in a room so that the chance of a shared birthday hits 50-50? A clean coin flip. Most people, hearing 365 days, guess something big. 150, 200, half the calendar, give or take. That instinct is so common it has a name, it just feels right. Lock in your number. How many people for a 50-50 shot? Hold that guess. We'll come back for it. Let's see why our gut reaches for such a big number. When you picture this, you probably put yourself at the center. You think, how many people would I have to meet before one matches me? And that really is a lot. Each new person has just a 1 in 365 shot of hitting your day. So to get even close to a coin flip on your birthday, you'd need hundreds of people. Your gut isn't being dumb. It's answering that question perfectly. The trouble is, that's the wrong question. The bet was never about you. It was about any two people matching. And once you stop standing in the center, the numbers change completely. Here's the move that flips everything. Stop counting people. Start counting pairs. A shared birthday needs two people. So what matters is how many pairs of people exist. Let's count them in a small room first. With two people, there's exactly one pair. One possible match. Add a third person. Now, they pair with each of the first two, plus the original pair. 3 people make 3 pairs. For people, 6 pairs. 5 people, 10 pairs. See how fast that's climbing? People go up one at a time, but pairs go up in leaps. The formula is simple. Each person can pair with every other person. For a room of any size, the number of pairs is the people times 1 fewer, divided by 2. Now plug in our party. 23 people. 23 times 22, divided by 2. 253. 23 people quietly hide 253 pairs. That's 253 separate little chances for a match. Sit with that gap for a second because it's the whole secret. 23 people barely dent a calendar of 365 days. But 23 people create 253 pairs. Each pair is a tiny lottery ticket for a coincidence. Any one ticket is a long shot. Most pairs won't match. But you're not holding one ticket. You're holding 253 of them. Buy enough long shot tickets, and winning somewhere becomes the safe bet. That's the trick your intuition misses. You feel the people, which grow slowly. You don't feel the pairs, which explode. And it's the pairs, the coincidences piling up, that win me the bet. Okay, intuition's on board. Now let's get the actual number, carefully. Computing the chance of at least one match directly is a nightmare. There are too many ways to win. One pair, or two pairs, or three. So we use a classic trick. We compute the opposite. What's the chance that nobody shares a birthday? Everybody totally unique. If we get that, the chance of a match is just 1 minus it. Done. So let's walk people into the room one at a time and demand. All different. The first person walks in. No one to clash with. Any day is fine. That's all 365 days free. The second person walks in. To stay unique, they must dodge the first person's day. That leaves 364 good days out of 365. The third person has to dodge 2 taken days, 363 out of 365. The fourth dodges 362 out of 365. Every new person has 1 fewer safe day. The fractions keep shrinking. To get the chance that everyone is unique, we multiply those fractions together. Why multiply? Because each person has to dodge, and the next, and the next. Every all different has to hold at the same time. So we chain them. 364 over 365 times 363 over 365, and on down. Each fraction is a hair under 1, so the product only ever shrinks. With 10 people, the chance everyone's unique is still high, about 88%. So a match is only around 12%. The bet's a loser there. Push to 20 people. All unique slips to about 59%. A match is up to roughly 41%. Getting warm. Now, 23 people. Multiply all the way down, and everyone unique drops to 49%. Just under half. Which means a share birthday is 51%. Just over half. There it is. 23 people. The coin flip tips. Remember the number you locked in earlier? The one for a 50-50 room? 150? 200? The real answer is 23. 23 people. Not 200. Not 100. 23. And it gets wilder fast because those pairs keep exploding. With 30 people, a shared birthday is about a 70% chance. With 50 people, it's 97%, nearly a sure thing. By 57 people, you've already passed 99%. And by 70 people, 99.9%. 70 people, and a shared birthday is basically guaranteed. The curve doesn't crawl up to certainty. It sprints. I know. A curve is just more math. So let's stop trusting formulas and actually do it. We'll have a computer build random rooms of 23 people over and over. Each room, hand all 23 a random birthday, then check. Any two the same? If yes, that room's a match. Tally it. Next room. Watch the first rooms roll in. Match. No match. 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 It's noisy at first, bouncing all over. But as the rooms pile into the hundreds, then the 1,000, the fraction of rooms with a match settles down. And it settles right around 51%. 1,000 random rooms, no theory, just counting. Just over half of them had a shared birthday. Exactly what the math promised. The bet was good all along. So why does this fool almost everyone, every time? Because we count what we can see, the people, and people grow slowly. We never feel the thing that's actually exploding, the pairs. Coincidences don't need a connection to you. They just need 2 of anything to line up. And in a crowd, there are far more innies than your gut will ever credit. Here's the fun part. You can test this yourself today. A soccer team on the pitch, both sides plus the ref, is about 23 people. So there's a coin flip chance 2 of them share a birthday. Go check a roster. Or your group chat, your class, your office floor. Once you cross 23, bet on the coincidence. You'll win more than you lose. And one to chew on in the comments. This same pile-up of pairs is why password collisions and lottery coincidences happen way more often than anyone expects. What are the odds? It turns out much higher than they feel. Go count the pairs. I'll see you in the next one.